Here's where the real work comes into place. Is now with all of your background knowledge of the implications, biconditionals, your overall set of conjunctives and all of those truth tables and truth values and the equivalencies that they have, now you're going to go ahead and start getting this. And that is constructing an equivalency and a proof. So what you're going to get is you're going to get a question that looks basically similar to this. You're going to get asked, hey, prove that the left-hand part is equal to the right-hand part. Now, there's going to be some of them that will actually ask you to do this in a truth table format, which takes a while, or excuse me, or they're going to go ahead and use this as an equivalency like you have here. So you're going to see some work in another example here in a moment, and you've seen this already before, is that the left-hand sides and right-hand sides are literally showing the work that's being done to get one half to match the other one like it does down here. So it's very similar to the math homework that you and I remember and love, I guess. You've got to show the work. You've also got to tell me what you did in order to get to that next stage. That's what the grader is going to be looking at, is your logic and your result from that to get down to a very simple match in this example. So notice I'm going to do a very step-by-step approach when we come to this. Notice also I'm using different equivalencies or De Morgan's law or some of the other laws that we've gone over. So none of these are laws or equivalencies that you haven't seen before. So again, remember, you have two things, equivalencies and laws. They're going to help you out with this. But I'll show you an example here in a second. Here's our first full-fledged example. Now, to be honest with you, you really should have that sheet in front of you that has your equivalencies. It also should have your laws in front of that, just so we can kind of go over really what's happening here. I'm trying to do it step by step, so that's why you're going to see some things hidden here, because you're not going to be able to do that when you're doing your homework. So step by step wise, when I'm first looking at literally our first sentence here, that really looks like De Morgan's. We have a negation out front, we have some parentheses, we have a or symbol in the middle. That's going to match De Morgan's second law. That also means that we're going to be able to get rid of some parentheses, which is good too. So, which is funny because I'm actually going to add them here in a moment, but I'll tell you about that later. So that's why we end up getting that second equation that we have here of not P and then you see the rest of it being highlighted. Now, what am I going to do with that? Now, in reality, I'm going to do the De Morgan's again. There's a negation, there's our set of parentheses, and then we have an and in there. That's our second De Morgan law. So, well, we get rid of that part. We finish up with the De Morgan's and flip it. And you'll notice that now we have our not P and a double negative or a double not of our P and or not Q. Boy, a lot of knots on that one. But anyway, so I'm going to take care of the double negation law, getting rid of the P's. And then we end up with the next one. So in reality, you're going to see something kind of pop up here or actually disappear. We have not P and P or not Q. Now you're kind of wondering, well, wait a minute, that doesn't fit anything. Well, in reality, if you don't see if anything fits something, that usually means I can put parentheses around something, which is now being highlighted now. And now it actually goes ahead and uses second distribution law where I added the parentheses to it. Just doing that opens up a nice can of worms really in a good way for us, because then we have some things that you've seen before that we can start reducing. Notice we did the distributed and frankly expanded things, but it gave us more options, especially with that not P and P. We can go ahead and use the double negation law to go ahead and get rid of that and have that be a false. Then we have our or with that. So we end up with our F or our negative or not P and not Q. So what's that going to use? We're going to use our commutative law, go ahead and flip it. And I really didn't have to do that part, so just a heads up, I really didn't need to do that. I preferred it just because it matched the form of what we have for one of our laws. And then we're able to use the identity law to go ahead and get rid of the F because that is an or. And remember, with an or, we're always looking for trues, so the false really doesn't hurt anything, so get rid of it. And notice, whew, man, we actually have a match all the way from our original down to now all that work in between. But notice each step I'm identifying, I have to use an equivalency. or I have to use a law. I don't think I used any equivalencies on this one. Nope, they're all laws, which is unusual, but equivalencies do happen once in a while. One of your examples is going to happen eventually. But this one's every step I used a law. The only thing that was the trick out of this is two things. Using a form to have it fit something in our laws or equivalencies, or if I had something flat that really didn't have any parentheses at all, I went ahead and added them so I can have it fit in one of the forms that we have for a law, because it really didn't hurt anything either. So, hey, I focused on this side instead of that side. So, but anyway, so that's our example for this one. And then I want you to start getting to work on this one. Go ahead and work on that one, and then go ahead and give me, well, frankly, give me a solution, and we'll go from there.